Hello, today we are going to talk about Doxygen, which is a tool that takes as input source code, and especially the comments in the source code, also the structure, the members of a class, the class hierarchy, and produces as output either HTML websites that look like this or PDF. This is the official web page of Doxygen, doxygen.nl. Let's first generate from existing source code a PDF and an HTML version and see how they look like, and then we'll research a bit more and see how we actually put comments in the source code such that they are reflected in Doxygen generated documentation. So I have this KD Git repository named KIG, and I'm going to generate the Doxygen documentation. The command lines are two. Doxygen with as parameter a configuration file that looks like this. Let's run the command. It's done. And now the HTML files will need some images, which we're going to copy. Okay, let's look at the generated directory. Everything is generated in a subdirectory named build. In this case, inside of the latex directory, we have pieces. Let's sort by size. There's pieces of PDF files, and we can combine all of these PDF files into just one PDF file. There's a makefile available in here. If we don't specify any parameter, it will generate the PDF. So we're going to just run in this directory make. Okay. Again, we're going to sort by size descending. The biggest file there should have extension PDF. It's 430 kilobytes, which is really small because it does contain a ton of images. It has HTML links. It has mathematical formulas, which actually use LaTeX behind the scenes. Let's go to the classes. Okay, so per each class, there's an overview of the class, then there's a list of member functions, static member functions, constructors, etc. Relationship between classes. There's cross-referencing. Let's look at the HTML output, which lives in the other directory in build HTML. The entry point is called index.html. Let's open with what? Google Chrome. Okay. It looks like this. These are those images that we just copied using this command line copy and then a list of images. The top tabs are these ones. So this is the overview. There's the class hierarchy and classes annotated. Let's look at conic cart. In here we have the graphics which are generated using graphviz dot executable. The tool will look at the class hierarchy and show us that conic cart inherits from object, which is being inherited by curve, then conic cart, and then conic arc. It shows the source code files, so it says that it's defined in conic implementation.h. You have the source code available with cross-referencing. Collaboration diagram, signatures of methods, so we have, if we have a source code file system, then we can generate either a full website that contains the documentation extracted from that source code, or we can have it in a single file in the PDF version. This is useful if you rely on the documentation more, of the documentation of a library, and less on the source code of a library. I have opened the KD Git repository KIG in the integrated development environment for C++ and Qt Creator. I searched for the definition of the class coordinate. It's shown in this file, so kig/misc/coordinate.h. You can see in the documentation generated using Doxygen the HTML version that it says that that's where the class is defined. It says include coordinate.h. Okay. We can also see that it's from the misc directory. And now let's read a bit the documentation that's presented in Doxygen versus the documentation that's presented in the .h file. So this is a Doxygen docstring block, similar in syntax to the Javadoc from the Java programming language. Says the coordinate class is the basic class representing a 2D location by its X and Y components. So the line breaks are being removed, the one after location, between location and by, and then extra spaces are being removed, as you would expect to create a single sentence. It has all the relevant arithmetic operations properly defined, comma, and should be straightforward to use. So there's two dots in here. That's a bug, should be fixed. Okay, next up, there's the constructor with two doubles. So a coordinate is a point, which is to the location. So to a point as determined by its X and Y values with a floating point. Okay, This is the signature that's extracted straight from the C++ source code, because Doxygen does static analysis on the C++ source code and extracts the signatures and understands those and does abstract syntax tree. And then the rest of the documentation, this thing, is presented in here. Okay, so constructor, and then construct a new coordinate. So this should be constructs with a given x and y value. With given x and y values. Then there's another constructor which receives as a parameter a const reference of coordinate. So a copy constructor as defined and documented here. This copy constructor construct a new coordinate and give it the same value as p, and gives it constructs a new coordinate and gives it the same value as p. Constructs a new coordinate with the given x and y value. It's saying value in the sense that x and y are a pair, a tuple. Constructs a new coordinate and gives it the same value as p. Okay. Constructs a new coordinate with x and y initialized to 0, which is a constructor with no arguments, no parameters. And then there's the destructor. Okay, let's see these things. So the constructor with without any parameters. I'm not sure why the documentation was not extracted in here. Let's see. If not, creating Python scripting doc, default constructor. If not, creating Python scripting documentation. Okay, so this constructor might not be available from the Python scripting API. So might be only available from the C++ programming language, not from Python. Maybe that's what this if does, which ends in here. So if not, and then end if. A alternative structure inside of the Javadoc style Doxygen comments. Okay, then let's see also. So invalid coord, which is where? Invalid coord is a static constructor like thing, method. Create an invalid constructor. Creates. This is a special value of a coordinate that signals that something went wrong. 1 dot. Okay, and then it says see also coordinate valid. Let's see that thing. In here there's a see also block which only takes us to coordinate valid. Let's go there. Coordinate valid. This thing. So it's a object method, returns bool. computes whether the coordinate is valid or not. Okay. Do we have the C++ body of this function, the valid method, available in Doxygen? I don't know, but we certainly have it available in Qt Creator. So control click on valid and takes us to the implementation, to the body of the method, which computes what? So it's an AND Boolean with these two operands. So the left one says fobs, which what does it do? This is probably from the GNU toolchain, probably from glibc. Absolute value of x. We only have the signature of the function, not the body, the implementation in the C programming language, probably. Infinity as type double. Let's see what that thing is. So in KIG, the infinity as a double is defined as huge value, which is from the math C library, standard library. Value returned on overflow. This is plus infinity, or the largest representable positive value for doubles. Okay. Function overloading and operator overloading for C++ is shown in Doxygen with these fractions. So the first overload and the second one for operator multiplication. And we have the same thing for the seaters, for the constructors. That's the first and the second constructor with different arguments parameters. So \c, \internal, \and if, \brief, \if not are examples of Doxygen commands. Let's look at the documentation for Doxygen commands. So on the official Doxygen website, in the top bar, there's docs, and in there we have documenting the code. And then from the left tree view, this is a tree view that's collapsible, special commands. In here we have the complete list of Doxygen commands. So we're looking for C. They're not alphabetically ordered in the tree view. Equivalent to SA from C also exists in the Javadoc specification. I searched on Google for Javadoc, Let's see the wiki page. So it's a domain-specific language, uses doc commands. So in the Java programming language, there are comment blocks, which looks like this. The most standard of them all is to start with a slash and then two asterisks and with asterisk slash, and then have this column of asterisks 1, 2, 3, 4, and 5, which means having space asterisk on each line except the first line, including the last line. And then with the @ sign, you have Javadoc specific field syntax. There's param, return, throw, c, scenes, author, version. And this is what you have in the Java source code. Then there's also a executable, a tool that you give it as input a source code directory, and then it extracts from there the documentation, the doc strings, as a web page. Has been available since the very first Java release. There's support for some HTML tags. You can have the p HTML paragraph tag. Okay, a list of Javadoc tags. And then Java IDEs usually nag you if you're documenting a method and you're only documenting the first three arguments or parameters, and you do not have any documentation for the last one. For instance, it will say, hey, you did bother to create a Javadoc for the method for the first three parameters. How about you add documentation for the other parameter that doesn't have yet documentation? So when you refactor, change the signature of the function, change the name of the function, change the list of parameters, etc., you will need to make sure that you always update the documentation strings, the Javadoc, in parallel, in synchronicity. That's why I prefer to have the documentation string automatically generated using a tool. At least after I do my changes in the source code, I can tell the tool, please go ahead and rewrite the Javadoc such that it's synchronized with the source code. And if I rename the function, it will automatically rename the short description of the method. If I remove two parameters, it will remove these two Javadoc lines. And then it says that the precedence parts of the domain-specific language for the Javadoc are also valid in the Doxygen documentation generator. So back to the Doxygen commands. Let's see what some of the commands do. Okay, and we resize this thing. Okay, so internal is not meant to be used to generate documentation. This entire paragraph is missing from the documentation. So for the invalid coord, this is the documentation. And this paragraph, we represent an invalid coordinate by setting x or y to positive or negative infinity, is missing from the extracted documentation from the final generated HTML website or PDF as extracted by the tool Doxygen. Okay, let's look at C, \C. So C also exists in the Javadoc, equivalent to C also. Then we had brief. Starts a paragraph that serves as a brief description. So there's multiple paragraphs that can be used when describing a identifier, such as in this case a constructor. The simplest of them is the brief description. It should be a short paragraph, and that's going to be used also in tooltips when you hover on top of the class or on top of images. It's also used in classes annotated, in class hierarchy for this short paragraph that describes the identifier. The documentation of Doxygen says this. So for each entity, a C++ identifier in our case, there can be 2 or 3 types of descriptions. There's the brief description, the detailed description, and then could be also in-body description. So in-body description is comments, documentation content, comments that exist in the body of that constructor or function, in this case, method. Concatenation of all comment blocks found within the body of the method or function. Okay, it's not customary to have more than one brief or more than one detailed description. The brief description is a short one-liner. Detailed description is longer paragraph. And then brief descriptions are used to provide tooltips where you have references to that item. For instance, in these listings, in the listing class hierarchy, the brief description of the class conic polar data is available beside the class name. Whereas in this case, where it says the Cartesian conic data, if you hover on top of conic, it will show the brief description. An object representing a conic. Brief description in here also. And then if we find conic in here, which is this, it will have the same brief description. So the brief description of the conic type, which is marked here as uppercase C, so class, is an object representing a conic. If we go to the web page of the conic class, in here it shows the brief description. If we expand, it's going to also have the detailed description, which is also contains this paragraph. So the class conic has this detailed description. If we go to the top of the page, we will see in which C++ source code file the type is defined, so conic implementation.h, which is this thing. Conic imp.h. Okay, so we have this difference between the source code and what's presented by Doxygen in the generated documentation, because the generated documentation says that the type name is conic and implemented conic underscore imp.h. If we go there, there's no conic in here. There's only conic imp, conic implementation, with the exact same methods. So type, transform, draw, etc. The methods that are available in here. So transform, what's the magic? How come the source code, in the source code, the identifiers have one name, whereas in the Doxygen documentation, the identifiers have a different name? I have opened, using Visual Studio Code, the directory where I think that this change is being performed. So this is a directory with instructions on how to extract, using Doxygen, the documentation string from the C++ source code files. So somewhere in here, there's the magic that says that conic imp should be in the C++ source code, but in Doxygen should be just conic. And I search for IMP. I search for conic imp, didn't find anything interesting, but if I search for IMP with this exact capitalization, I get to this list of Unix sed invocations, and this invocation replaces the bogus IMP C++ identifier with the Doxygen identifier bogus object. String IMP, string object, int IMP, int object, etc. There's nothing in here for what we're after, which is the conic IMP. But then the last add, the last sed is this guy, which says IMP in the C++ source code if before it has a regular expression that says like this: any character, letter in the English alphabet, does not matter if it's uppercase or lowercase, 0 times, 1 times, or many times. So could be just IMP, could be a IMP, could be circle IMP, could be object IMP, whatever, is going to be replaced by this first match of whatever is in the parentheses. So circle IMP is going to be matched by this regular expression, and it will be replaced with just circle no IMP. The same for our conic IMP. So conic is this part, and then IMP, and is going to be replaced with just conic, this part. So using command lines that are available on your system, you can generate different identifier names in the generated Doxygen documentation versus what's in reality in the C++ source code in our case. Okay. So conic IMP is in fact this thing, this rectangle. Curve IMP is in fact curve, this rectangle. And curve IMP inherits from object IMP, which is again using the same sed, regular expression, being replaced from object IMP to object. Okay, in the generated HTML Doxygen documentation, you can click on these graphics. You have tooltips. When you hover on rectangles, you can navigate to the correct place. There's this handy legend. Let's open it in a new window, which says what each rectangle or arrow represents. So in this case, all of the arrows are blue, which is this relationship. So dark blue arrow, public inheritance relationship between two classes. The identifiers of the classes in this case might be documented or not. So this is not a valid Doxygen or Javadoc comment. That's why it says that the class is not documented. Class undocumented is presented here with gray, light gray border. This thing. For the C++ type conic, we had this inheritance diagram where we can see that conic inherits from curve, curve inherits from object. But you can also see what other classes inherit ultimately from conic. And the same if we go with object, we can see all of the classes that actually derive directly or indirectly from object. Then we have this interesting development where 3 source code lines, 3 C++ method signatures, lines 2, 6, 7, 6, 8, and 6, 9, have just one documentation block of comments. And the documentation block says the following 3 methods: get prop lead, get prop gid, get prop name. So these 3 signatures. The documentation block tries to document all of these 3 functions at the same time. So we can see it in here. We can see it, the following 3 methods in here, because the functions are really related. But then when the documentation is extracted by Doxygen, the methods that have zero documentation are not presented in here. So we can search for get prop GID. It's not present as a method. It doesn't say the method signature. It does say the signature of the first method, which has the documentation comment block above it. The documentation was extracted correctly. We can read it in Doxygen, the documentation generated by Doxygen. But then again, the other two public methods are not documented. They're public. They don't have any documentation strings, so they're not present in the documentation generated by Doxygen. Which is probably something that was not intended by the developers that have aggregated the documentation comments from 3 methods into just one documentation comment block. Okay, then there's another interesting thing, which is this. So for inherits, this is how the source code looks like, and this is how the extracted documentation looks like. So there's the signature, says returns bool, name inherits the correct type, the correct signature, and this IMP has disappeared. Just object type, not object IMP type. And this HTML part that has a yellowish background is this part of the C++ source code comment. So a block that starts with Doxygen command code, ends with Doxygen command encode, this thing, and another code block in here. Okay, let's see. So this is the sample code. If objects inherit line IMP S type and then colon, because this is Python source code. So if creating Python scripting doc, yes, that's true. We've used the source code is C++, but we have used Doxygen in order to extract documentation that will be used from the Python programming language. So that's why some of the code samples are written in the Python programming language, not in C++. Okay. If we click on line, it takes us to the class line. And doesn't have tooltip. Okay. Says definition on line imp.age 170. Yeah, it doesn't need a tooltip because this is the brief description of the class line. So this is the name of a class. This is its brief description. And this is where this class is defined. Okay. Line S type is a method with this signature. And this short description. This thing. Okay. Why don't we have the second code sample? Because of the if command in Doxygen. So says that if we're creating Doxygen documentation for use in the Python programming language, if and then else, use this code block. If we're creating Doxygen documentation for programming in the C++ programming language, then the code example uses C++ syntax. So parentheses around the condition, this thing, and no colon. Let's look at the documentation for the method attach point. So the documentation starts with returns, then many words, and then finally a dot. So mechanism dot, a full stop. The first sentence, which ends with a full stop, is being used as the brief description, which is very, very long for a brief description. Says that brief description should be a short one-liner. So this is what we should do when we put documentation on identifiers. We should make sure that whatever Doxygen extracts as the brief documentation of the brief description of that identifier is a short one-liner. So in fact, this huge phrase should be broken in at least two parts. What we want to have as a short one-liner brief description and the rest of the phrase. And there's also an uppercase T in here, which means that it is probably missing a dot here. And maybe also here. I made these source code changes. So I put a dot instead of a semicolon, uppercased the first character in the next sentence. I have regenerated the Doxygen documentation using the same command line. So Doxygen doxyfile dot scripting minus API, and then copy the image files. I refreshed the page. And now when we look at attach point, this short one-liner is shown as the brief description. And this is the complete description. So there's a brief description, detailed description, and maybe an in-body description. Or constructors, methods, static methods, functions. In the integrated development environment Qt Creator, we have this outline tool window. And all of these grayed out things are forward declarations of classes. We're inside object_imp.age. The type that we're interested in is object IMP. This one. Let's look for the type method. The identifiers are not sorted alphabetically. And we have the same type of, the same pattern of code samples. We have a special code sample for the Python programming language and another code sample for the C++ programming language. This documentation was generated for use in the Python programming language, so this is the source code sample line that we have. For example, if you want to get a string containing the internal name of the type of an object, you can do, and then the code example. And then it also shows this base class, which is object, as the method type, which is override virtual, implemented in the classes that inherit from object. So in conic, circle, arc, point, etc. And then from conic, the conic class, the classes circle and conic arc inherit. So it says that the method type from the class conic is re-implemented in the circle and conic arc. So conic arc inherits from conic, and circle inherits from conic. So methods that don't have any documentation comments are not presented by Doxygen, and neither are classes that have documentation, but then the comments of the documentation doesn't use any of the syntaxes that are supported by Doxygen. And those syntaxes would be Javadoc C style, Qt style, so exactly like the Javadoc, but this second asterisk is replaced with a exclamation mark. This can be missing and this can be missing. Or at least two comments, but then you in fact need 3 slashes or 2 slashes and an exclamation mark. Just simple slash slash C++ style line comment is not enough. Will not be treated as Doxygen documentation comments. Then you can also have banners, which look like this. This is the first possible syntax. The second or the third. And you need to make sure that you have this variable defined. So Javadoc banner, make sure it's set to yes. Let's see what the value is in our configuration, or if it exists, this configuration in here. So it's this thing. Underscore banner. It's not defined at all. Which takes us to the Doxygen project file. So in Doxygen speak, this is called a configuration file. It is a plain text file. You give it as parameter to the executable Doxygen. Case sensitive. All of the lines that start with the hash sign are comments and are being ignored by Doxygen. And then there's statement lines that is a tag name followed by an equal sign and then a value. This is a string value. This is probably also a string value. So it says that values that contain spaces should be placed between quotes. That's why there's no this value is not enclosed in double quotes because it doesn't contain any spaces, and neither does this /build, which is the output subdirectory. Okay. It supports more languages than English for internationalization purposes. Alphabetical index of the tags that are recognized, followed by description of the tags grouped by category. Let's look at some of these. Output directory. The output directory tag is used to specify the relative or absolute path, in our case it's relative, into which the generated documentation will be written. The relativeness is to the location where Doxygen was started. So it's the current directory, pwd, of the when you started the process Doxygen. Okay, create subdirectories. We'll create almost 5,000 subdirectories in 2 levels. If you feed Doxygen a huge amount of source files, if the file system does not support millions of files in the same directory. Okay. Output language, possible values. The output language tag is used to specify the language in which all documentation generated by Doxygen is written. Doxygen will use this information to generate all constant output in the proper language. So we can see that this doxy file was somehow generated using Doxygen a long time ago, like 20 years ago in this case. Okay, so the important tags in here that needed to be changed in this case were project number. This is the version of the build. which this KIG is a C++ programming language project, and part of the build machinery, it will generate a .h include file that contains the current version. And then I needed to copy the current version from there and paste it in here. Okay. We have options of extracting methods that are not public, that are private, statics, and you can also have available in the documentation generated by Doxygen also the identifiers that do not have documentation. It says Doxygen will assume all entities in documentation are documented even if no documentation is available. So if you do not have valid Doxygen style comments for the identifier will still be extracted in the generated documentation, and Doxygen will at least show the signature of that identifier. Hide undoc members. Doxygen will hide all undocumented classes. Extract all is more powerful than hide undoc classes. Hide undoc members, yes. We'll hide all undocumented members of a class, even if the class is documented. The default is no. Which is the correct default. So if you don't yet have Doxygen style comments on your C++ source code and you run Doxygen on your source code, it will still document all of the identifiers and methods and just present the C++ signature for those identifiers, no brief descriptions or detailed descriptions. But then this documentation was created for use in the Python programming language, and maybe not all C++ identifier are being exposed to the Python world. Okay, in here we have the paper type to be used by at least the PDF generator. I have enabled PDF hyperlinks and PDF LaTeX. I have enabled generate LaTeX, yes, because that's the way you generate PDF files. So first you generate the LaTeX output, and then there's a makefile inside of that directory, which you then run. So inside of the build directory, you have a LaTeX directory, and by default, you do not have the PDF file that contains the concatenation of all of the data, that's all of the files that are inside of this directory. So all of the graph views dot images and all of the PDF snippets of this thing. Okay. Let's look a bit again at the makefile. So there's manual file.pdf, and the manual file name is refman. It's using PDF LaTeX as we instructed it. Okay, there's a make file target clean, which removes the intermediate files, including the PDF, and all or PDF or manual file PDF just generate the large PDF, the final PDF. So we just run make. Still, the output is not good enough because it doesn't contain the images. So this image, for instance, I cannot find it in the generated final PDF. So this is probably a builder error that I need to actually fix. And it's shown probably in here. It needs a bit of debugging in order to fix it, probably. There's the possibility to generate other types of output except LaTeX, PDF, and HTML. There's generate man to generate man pages. There's generate Windows style RTF, rich text format. We have the list of files, source code files that should be taken into consideration when creating the extracting documentation using Doxygen. So we have .h header files, C++, class and other identifier definition files, plus an additional file with the extension dox, which looks like this, uses Doxygen commands. It's just one Doxygen command, and it's being used in order to feed this homepage, the index.html homepage of the Doxygen generated web site. This has main page, which is a Doxygen command, AIG Python scripting API documentation, also shown here, and then 3 sections: introduction, the API, and links. Okay, this API is mostly meant to be used from user-defined calc functions. In these functions, it is necessary to li would be list item, access the information, \ref for reference, and then object imp again is being replaced with just object using that sed. There's no need to actually use \ref because even if you just say object imp, it will still show a hyperlink to the object page, class object.html, and the correct hover tooltip. Both uses require the object API to be exported to Python, and this is the major part of this API. Some more classes are also exported, but mostly because they are used from one of the objects APIs. Okay, let's see where this very antiquated string comes from, because KD-libs does not exist in KD frameworks 5 or 6. Let's see in here. So there's a footer.html file, and then in the generated build subdirectory. Okay, so footer.html is important. How is this thing included? In the doxy file, it says that HTML footer is this file, footer.html, and then there's another which is header.html. There's also CSS style sheets. Then we have also in the doxy file says enabled sections. The value is creating Python scripting doc, which is this value that's being used as a Boolean value inside of the if Doxygen command. Can be used to enable conditional documentation sections marked with backspace if and backspace and if. There is also support for other Windows style technologies for containing documentation. There's the Microsoft Help compiler, HHC. There's CHM files. Then it says the technology that's going to be used in order to generate the PNG files with a relationship between different classes. Says that it's going to use dot, which is GraphViz. And then it says that dot will generate PNG files. This legend, this functionality, so showing the link to the web page graph_legend.html, is toggled in here. If you put no, this page will not be generated. I have changed about 5 of these Doxygen configuration tags, and now the documentation has a left-hand tree view, which it did not have before. The theme is the default theme that's shipped with the latest version of Doxygen that we're using here. It's not the CSS that was provided by the KIG project. And I also enabled search functionality. I search for circle. And it works. And the general look is way better. And then I have also enabled the UML style graphs. So the PNGs used to be just rectangles with the name of the class, and now they also have the list of methods and different type of arrows between types. This is what I have changed between the last run of Doxygen, which creates Doxygen web pages that we expect. We're using the latest default look of Doxygen generated documentation HTML websites, and the previous, which used the KIG provided looks. Let's look at the differences. So I have removed HTML header, HTML footer, HTML style sheet values for these Doxygen tags. Then I'm saying that I want a tree view on the left hand side of the page. And the final change, that I want the PNG files generated using GraphViz using dot to not be just rectangles with class name, but to be UML style. This is a bit too much, totally. Seeing all of this complexity here is a bit overwhelming, so we should revert. These are needed in order to generate PDF files. So PDF hyperlinks use PDF LaTeX and generate LaTeX, yes. Generate review seems useful to me. And not having these three, we probably need to customize the header and footer, but we probably need to not customize the style sheet. So there's just 4 changes: HTML header, HTML footer, HTML style sheet, generate tree view. 4. And I also have enabled the search engine, which is this edit box that actually works. Let's select just classes and go circle again. And the HTML generated for the include files is way better. It has syntax highlighting and it has the correct indentation, because previously everything was this space was missing. So it's totally an improvement. I should propose that we change in the KDE Git repository for KIG the way we generate Doxygen to use the current CSS. Because with the previous CSS there were various regressions, so the source code did not look okay. Let's generate again, such that we don't have the UML style PNGs. This is the default look and it's better than what we had previously. and the graph legend looks way better. So there's all sorts of advantages in not using a CSS file that's 20 years old. Let's now see how you install Doxygen. So I have removed most of the packages from my Linux operating system that are related to Doxygen. So I'm using Ubuntu 23.10. I'm going to run the same two command lines, and I guess that we'll have errors here. So let's see. Says that there's no executable /usr/bin/doxygen. Let's try to find this thing. First of all, let's install apt file. Okay, apt file update. Man apt file. So apt file and then search pattern. There's substring match. And there's ignore case. And the verb is this one, search. So apt file space search and then pattern. Apt file search Ctrl+Shift+V. Says that the deb package that I'm looking for is named Doxygen. Let's install it. Because that's the deb package that provides this file /usr/bin/doxygen. It automatically suggests correctly, which is viz, graph viz dot for PNGs and LaTeX for 2 reasons. In order to show mathematical equations and in order to generate PDF files. We've installed just Doxygen for now. Let's see if the command line works. So it does, but then does the HTML output look okay? So instead of a PNG file in here, we have just this text inheritance graph. The actual PNG files are missing, so we'll need to enable those. So the suggested is graph viz, which is correct because the executable that we're looking for is dot. Okay, so it says that we should install dot. Let's search for that thing. This is probably the name of the executable /usr/bin/dot. And we need to not search substrings, but search entire strings in here. This is graph viz, the name of the deb package. Middle click paste from selection, from primary. Okay, we'll install graph libraries, fonts, Let's generate again Doxygen and then the copy images. Refresh. And now we have the PNG files. What exactly is in here? So it's an area shape rect. It's not actually PNGs, but it's HTML using area and HTML map. That's why we can click inside of the images. So we cannot click on abstract line because this is the page that we're currently on. But if we click on curve, it will take us to the class curve.html file. We see here. Okay, and the last things that we're missing is generating PDF files and having inline mathematical equations, which we actually do have in this project. So in the class list, it's showing the brief description of classes. So for conic polar data, we have this thing, $, \rho, parentheses, \theta equals \frac, etc., which is LaTeX for mathematical notation. So it's not rendered correctly here neither. Okay, so I'm going with a suggestion. When I installed the Doxygen deb package, it suggested that I also install Doxygen LaTeX, which I'm going to do right now. So apt install this thing. We'll install 1 GB of packages or something like that, because it will install Java and the TechLive LaTeX distribution. And many Perl packages. And PostScript and additional fonts. It's an entire distribution of LaTeX. Okay, let's run the generation again using Doxygen. So Doxygen 1 and copy. And then when we refresh, we expect this thing to be converted to something human readable, which it is, this thing. So this is theta, this is e, this is cosinus, cosine. Okay, and the build subdirectory should have a LaTeX directory, which it now has, where we can generate the PDF file. And it's going to be named refman.pdf. Okay, where is that LaTeX on conic polar data? Class index, class list, conic polar data. This guy. So it's available here. and here. So this is it. This was how to use Doxygen, how to install it, how to add documentation comments to your C++ source code, which respects the Doxygen domain-specific language specification, how to have a Doxygen configuration file for your project, how to run Doxygen from the command line, what are the Doxygen commands and configuration tags, two types of outputs, the most common ones, PDF and HTML websites with search functionality, how to generate the graphics correctly, how to have inline mathematical notation using LaTeX. This is it. Thank you.